Okay, so suppose I wanted to simplify this surd, right? Obviously I could use a calculator, right? And the calculator will do it for me in the exam, right? So if I press root 20, okay, and press equals, it's done it for me, simplified it to root 5, okay? But it's good to know the sort of skills that lie behind that and why it's 2 root 5. Quite simply, what we do is we think of a pair of numbers that multiply to give 20, okay? And preferably one of those numbers being square. So, I could say 10 times 2, but, 10 and 2 are not square. The other two we can think of is 4 and 5, yeah? 4 times 5. And so I can write 20 as 4 times 5. And the good thing about surds is I can split them up. So I can write that as root 4 times root 5, okay? They can be split, all right? And then we could determine then from here what the root of 4 is, because we know the root of 4 is a whole number. We get 2, don't we? And then times root 5, so we'd write that as 2 root 5. Okay, so what I've done there is I've simplified my surd. In other words, the number under the root here is bigger than what I've got in my answer, right? My answer's got a smaller root, okay? So hence I've simplified it. Okay, you could keep going. There's lots of different examples. You could do, for instance, root 18. Okay, and root 18, a pair of numbers. We could think of 9 and 2, yeah? 9 times 2. Split that up. That would be root 9 times root 2. And of course, root 9 is 3. So 3 times root 2 is 3 root 2. Okay, lots of other examples, okay, that you could be asked. Root 48, for instance. Okay, 48. Two numbers that multiply to give 48, one of them square. Well, we could go for 16. Okay, 16 times 3. Okay, 16 is a square number. If we split that up, it would be root 16 times root 3. And root 16 is 4, isn't it? Okay, and so that'll be 4 root 3. All right. Now, that's good, and that was useful for skills that we need later on. Okay, so the other thing we could be asked then is the reverse process. We could be asked to do, for instance, root 5 times root 2. We could be asked to sort of multiply them together, and that would just be root 10, wouldn't it? Because if we were asked to multiply these together, we could do the reverse process and put them back together, okay? And we get root 10, all right? Similarly, I could have root 5 times root 3. Now, I could just go for the answer straight away and realize then it's root 15, okay? I don't need to put it under one root, okay? I can just, I don't need to show my workings. I could just go straight away, say it's root 15. Now, what's interesting is when we get a root times itself, okay? Because suppose I've got that, root 5 times root 5. Well, if I put that under one root, okay? Of course, we know 5 times 5 is 25. And when I square root 25, of course, I get 5, don't I? So root 5 times root 5 ends up as being 5. And, I could do the same with root 7, for instance. Root 7 times root 7. Well, that's the same as root 7 times 7. That's the same as root 49. And root 49 is 7. So what happens is when you times a root by itself, you get the number that's in there. So we could do that for any case. We could do root 10 times root 10 is 10. Okay? Root 17 times root 17 is 17, okay? Right, that will always be true. The calculator will say that as well. Root 63 times root 63 is 63, okay? That's always true. All right? So we've seen here about multiplying different surds together and then surds that are the same. If then we get a situation where we've got, for instance, to simplify this, 2 root 7 times, say, 3 root 2, okay? What we do then is we multiply the big numbers together, so 2 times 3 is 6, okay? 2 times 3 is 6, and then we multiply the surds together, root 7 times root 2, well 7 times 2 is 14, okay? So we end up with 6 root 14, okay?